Okay, so of course we talked about the variable names. Now the variable, it's very important, this has to be right. And the variable could be, let's say, a name, an age, an address. It could be, let's say, somebody's height. We can only use those declared variables to keep items in them temporarily. So if you look here, let me see. Can you see my screen? Is it wide enough?
Yeah, I see the Unity slides.
Yeah, okay. So keep me in mind, now Python, like we said, is a very popular language. And these are some of the things when you're looking web development, when you're looking software development, as in scientific, for example. And this can even do e-commerce and even social media websites. This one can do mathematical. This one can also do scripting, because with Python, you can link to other languages like Java, C, or C++. Any other language can work with it. Now, again here, of course, we can use it on the server side alongside other languages, and we can also use it alongside software to create workflows. And we can also connect to a database backend, and we can connect to, give me a name of the database, Python will be able to connect to it.
Database, when you connect to Oracle, SQL.
Yes.
DB2.
Yeah.
MongoDB.
MongoDB. Neo4j too. Neo4j. Access, here you go. If you want to use Access. And Python can also be used to handle big data, and big data we talk of Hadoop or Spark. And Python can also be used for rapid prototyping. Like the advantage it has, it's so easy to learn and use, but that if you want to demo something real quick, you can put it in a prototype using Python to show to, let's say, a client. And so that you can basically showcase it to be able to tell them, hey, this can be done. Then once they approve it, then you continue it. And now somebody might ask, why Python? Now Python can work on Windows. It can work on Macintosh. It works on Linux. It can work on Raspberry Pi. Raspberry Pi is a very small computer. Normally we use them a lot in colleges for experiments. So they come with like a circuit board and everything, and it's very small, like size of a soap.
Okay.
Yeah, so Python has a simple syntax. So that's why it's so easy to learn and use. It has a syntax that allows developers to write programs with fewer lines of code. That's why it's so easy to prototype in. And it runs on an interpreted system. So Python is interpreted language, meaning that the code can be executed as soon as it is written. And that means that prototyping can be very quick. And also it can be treated in a procedural way. So Python is object-oriented. We can also use procedure-oriented way in this form of a function. Okay. So these are some of the features. Now it's free, readable, easy to learn. You cross-platform it from Linux to Mac to Windows. It's open source, it's free. Exceptional handling is very good at it. Large standard library, yes. Big community support, and also very good in memory management. Now, the most recent major version out there is now 3. We used to have like Python 2, and then it stayed for a long time in 2.7, which some people are still using. However, Python 2, although not being updated anymore, but right now the most popular is 3. Very popular now.
What is the major differences between those two versions?
Now, the difference between the two versions is the way the constructs are. For example, in Python 3, if you need to, let's say you need to print, say you need to do a print statement like this one.
Mm-hmm.
In Python 2, 2.7, you don't need a bracket. You just do print. And then we put the name here. The name of that thing.
That's Python 2.
So yeah. So that was changed. And now in Python 3, we have to have a bracket. That's one big difference. Another difference is Python 3 has more support for more libraries, which were previously probably not available. And they keep on coming more and more as time goes by.
Okay.
So that's a big difference. And there are so many other differences, some of which we will be able to talk about as we go along. So Python, you can use it in pretty much any text editor. For example, we downloaded PyCharm, we downloaded VS Code, you have notebook, Anaconda notebook. We also use like Google Chrome. So we have so many, and all of them, they work without any problem. So that tells you how Python is very flexible. Now the syntax, when it was designed, Python was designed for readability and has some very similarities to English. When you read it, it's just almost like reading an English language. Now, Python uses new lines to complete. So Python is very big on indentation. And as opposed to other programming languages like, let's say, Java, where you'll be using a lot of parentheses, Python will be using indentation and spacing. Also, Python relies on indentation for syntax highlighting, using white spaces to define scope, such as scope of loops, functions, and also in classes, which we will be able to talk about, loops, and then also functions pretty soon within, let's say, a few lessons to come. So you see, you did Java. In Java, we use a lot of curly brackets.
Yeah.
In Python, we don't use curly brackets as a syntax. Use indentation to space out our code. Sometimes if you don't get it right, you get an error message and you might be wondering, what's going on? My code seems to be looking good, but still I cannot get anything out of it. So you just have to be very mindful of indentation. For example, if you look here in our code, you see how we indent this one. See the for loop, and then we execute that, and then we print it. Now, if we don't do it the way it's supposed to be, you see, you get an highlight. So if you run that, your output will probably be different.
Mm-hmm.
But if you change that, you run it again, your output will be different again. So this one is showing us something which is not in relate to what we're looking for. But look now. We're trying to convert this being a list, and this is also a list, but we are combining both of them to form a dictionary. And this is the last assignment we did.
Yeah.
So when we form a dictionary, that dictionary, we have to declare a loop. This is a for loop. So we say for I can be like for I index in the range of length being the names, which is this one, And then we go ahead and say, this, we declare the dictionary array, and then we saved it in this one. And we say we want it to be updated so that we pair the name with the age. So if we don't get the indentation, we don't get this output right. Now, the same homework, you can also do it just by using the zip. If you look at the zip here, this is just a function for combining this with this one. And get it. Yeah. So Python is big on indentation. Now, it's very similar to programming. Now, Python is a very simple programming language. So even if you are new to programming, it's very easy to learn, as you can tell. So I'll give you this note, so don't worry, I'll share them with you.
Okay.
Okay. So now you might be wondering, why is it even important? Is it worth it to learn Python? Yes. Research and report reveal that Python is one of the most preferred programming languages in the 21st century. The reason behind it, its popularity, is its simplicity. It has a huge community following, and its easy inbuilt functions, libraries, packages, and modules that help in easy learning curve. Though the question depends upon who you ask. For a beginner learning Python, it makes sense because it's easy to learn. But you ask somebody who is probably, let's say, works at Lockheed Martin, I can almost guarantee they're using part of Python there. Because Python, the good thing, you can use it in joining other languages together. So a lot of tech giants, companies like, let's say, Facebook, Amazon, Microsoft, if they're not yet using Python, they will very soon start using Python, because Python has very good libraries which are being used in machine learning, in data science, in artificial intelligence. It also has a big implementation and the ability for huge library packages, which has proved to be money saver for a lot of organizations. So if you look here, these are some of the things. High package salary. If you have Python, you stand a good chance of getting the big dollar. It's easy to learn and execute complex solutions. Leading language in data science, machine learning, and artificial intelligence. The versatility and career advancement. If you have it, you can easily move across from one department to the other, or even from one company to the other. Job roles and the applications where we put Python into use. It's portable, it's extensible, supports a wide range of applications. So since we started, we've been talking about the variables. Now, these are some of the variable and the variable types. So this would be a very typical example of how you would like to declare a variable. Like, can be a single. This might not be very descriptive, but just if you say a name, then you probably want to say my name, my underscore name, or my underscore variable. And if you declare a class, you probably want to declare a class with a descriptive name, so that when you come back to it, it will be self-documented. You can easily figure out what it was meant, or what you actually meant when you declared it. So we start each word with a capital letter. This is just conventional. It's not a must, but it's always good to follow some uniformity. So you do not separate words, underscore, and then you try to join them, either camel case like this one. Sometimes they call it Hungarian. format. So, no, let me see. So here, we talk of function. We use a lowercase add words to separate words by underscore to improve readability. The variable declaration is how you do it. The class, we start each word with a capital letter, so we don't separate words with underscores. This style is called camel case. Use lowercase word or words, separate words with underscore to improve readability. So when you talk of method here, and you talk of functions in Python, these are more or less the same. Now, when we talk of functional or procedural programming in Python, we normally refer to a small piece of program as a function. But when we go into the object-oriented aspect of programming in Python, we call it a method. But overall, they mean the same thing.
Okay.
Yes. So use a lowercase word or words, and then we separate those words with underscores to improve readability. So this one and that one are more or less the same. And then, of course, we have a constant. Say, for example, pi r squared. Now, in pi we know it's always 3.14 or 22/7. When you declare a constant in Python, they always conventionally recommend that we use a capital letter. I mean, caps. So we use a constant, or we can use something like this, my constant or my long constant. So use an uppercase single letter, word or words, but if you really have to, you can separate words with underscores to improve readability. Now we can also use, in the modules, we use a short lowercase word or words, separate words with underscores to improve readability. You can also use a short lowercase word or words, do not separate words with underscores whenever you do the packing. So in this class, we will be able, when the programming goes to real serious programming, we'll be able to create our own modules, our own packages, create our own constant, do our own method or functions. Of course, we've already done the variables and also create our own classes. So we'll be able to see that and how it works, especially when we go towards the end where we have like an individual project we're going to be working on. So usage of examples of variables. So this one, like for example, we have A, Nelson Mandela. I don't want to do that because A might not mean anything to anybody, but how about we just say first, we just say full name here, then we say Nelson Mandela. So instead of A, you can say full name. Then we come here and then we say B, comma C, and then we split. Now, what does that mean? Let me go ahead and show you. Let's go ahead and copy this here. Bring it here. I'll share this with you too. So we have this particular code. The code is correct, but it's ambiguous. It might not make a lot of sense to somebody who wants to come back to it, but they don't know what to do. So here, let's go ahead and say, we are going to go ahead and declare a new variable. So we say first name, and then we want to say first name is Fred. That's first name. When you run this code, it just runs, and when you see a tick, this green check here means that code ran. But we don't know what the code is all about, right?
Mm-hmm.
So we want to see. Let's go ahead and print it. So if you are running in Python 2, you don't have to put a bracket. But since this is Python 3, you just say first name. If you are to print out, it's going to print out your name.
Mm-hmm.
But alternatively, we can go ahead and comment that. Now, instead, we can say we kept the first name like here, Nelson Mandela. Now, instead, we say Fred Tambo. We put it in first name. And then we say, we are going to go ahead and say, instead, we say B. So we say last name, comma, family name, for example. And then when you look at this one, this is a function. The function is telling us, take whatever was kept in A, but we want you to take that and then split it.
Mm-hmm.
The dot here is known as the dot notation. So when we say that, go ahead and say, hey, take whatever that name was, which is kept in here, but we want you to go ahead and put a dot so that we call a function and then we split that. Sorry, we split that. So implode it. Take the first name, but implode it. So now that we've done that, we are going to go ahead and say, once you do that, let's go ahead and save this one here. Now we want you to go ahead and print. Now what are we printing? We are going to print last name and family name. So it's going to be, hey, whatever that name was, it actually consisted of first name being Fred. So we take that Fred, we split it into two, and then we say, take those two, and then call the first one to be the last name, to be the last name, and then put a comma, and the first name to be the family name. Mm-hmm. But we are going to use a separation. So we do the separation, we keep that separation, the comma, into sep, short for separation. So when we come here, see here, we can say, in this one, take that family name, paste that, put a comma, and then we are going to go ahead and say, see like they did here. Now we take this one here, copy that, paste it here. Okay. Now we are going to go ahead and separate those two, but using a comma. So we separate those two. So we use a sep. Our separation will be using this particular character as a separator.
Why are you missing one of the bracket, getting a quotation mark on that one?
Quotation mark.
Quotation mark between sub.
This one, these are commas.
Okay, there's a comma, but then I don't know, single quotation. Go back on the top one.
On the what? The original one?
Yeah, Okine kind of self equals to Guinea. There's a comma. There's a
Yeah, so you're right. So what we need to do, whenever you do that, this one has to be in quotation. You have to put it in quotation mark because it's actually going to be treated as a string. So you're right. So when we do this, if we run this one, we have to run this one first so we can get it again. So we do that. Now we print this one out.
It's complaining because of that Guinea. I think one of the quotation mark you have both of them inside. One should be out. No, it's okay.
We have to have a quotation mark to separate the SEP and the last name.
Yeah.
Right there. If you do that, now it should be able to run. So if you run it, okay, 1 second. Let's not do it. Okay, kuruma okuni gubida reo, ni gubida chielka. Then print, so we don't need this one. It's just all in one. But if you look here, this should be an equal sign. We do the assignment. This one should be assigned to SEP. We separate them. So now if we do it again, it's going to be Tambo Fred. Yeah. So when you do variable declaration, you try to make your variables not ambiguous like this one. Try to spell them out. So this could probably be full name, right? So this is Fred's full name. Full name for Fred is Fred Tambo. And then once we get that, then we say, okay, now, you know that's his full name. So here we have to come and split them. So if we have to split them, then we are going to go ahead and say last name, and then this one will probably be full name. So this one has to change. If you do that, let's try that. Now this one probably is not there. Now king or kind, so whatever we saved in here, this should be full name. That's correct. But why is this not working? So this is C, this is C. So we come and say, what is the error message? The error message will always be
or declare. It's not giving a full name, no, or declare. Kineka full name, we have last name, comma, full family name is equal to full name.
Now,
full name, and then declare.
We declared it here. We have to run it again because.
Okay, or refresh.
Yeah, I'm going to refresh now. If you try again, it's going to be okay.
Yeah.
Yeah. So anytime you make a change, this is being an interpreted language, line by line. If you make a change, you have to go ahead and run it again. And then it does it. So, Mano, the key takeaway here is we have to always declare variable with a meaningful name.
So as a good practice, that's a good practice that should be, and also commenting out on the code, don't you? Just to explain what that code is doing block by block, don't you?
Exactly. For example, you're like, okay, now what I meant by this one is, I can say declare the full name. And then turn it out to something else. Okay, now split the full name into first and family name. And Okay, now here, 1, 2. Here, now this one, print, we want to output the full something like that. Okay. So far, so good for that in terms of the variable. Now, if I save that, you should be able to get it on your end. So if you go here, now the above will work, but can be quite confusing, this one. Because of this, they might not mean a lot unless your code is heavily documented. So we will have to keep track of what A, B, and C represent. It may also be confusing for collaborators. Somebody might come, let's say 2 days, 3 days, 10 days, 10 years later, when you are gone, and they try to figure out, and some of the lines of code could be thousands, even millions of lines of codes. So unless you document it properly, it can be very confusing, and they might not know what you actually meant. So much clearer choice of names would be something like this. Say names, Martin Luther. First name, last name. You split that into 2. Print, first and last name. Then so in Python, we also have something we call the Bitwise Operators. Now, these are being used to perform bitwise calculations on integers. Integers being 0 to 9. The integers are first converted into binary, zeros and ones.
Zeros and ones,
And then operators are performed on those bit by bit. Hence the name bit, the word bit by bit. This one right here. So if we do this, it's going to be taking that bit by bit wise operator. So then the result is returned in decimal format. Now operators are used to perform operations on values and variables. These are the special symbols that carry out arithmetic and logic computations. So you know, you and me, we know very well, computers don't understand English. They don't understand math. They only understand zeros and ones. So in order for us to communicate with the computer through any language, we have to give it some kind of level of understanding by giving it something which can help it interpret the zeros, the full meaning of that language into zeros and ones. Now, these are the special symbols that carry out the arithmetic. Now, the arithmetic being the plus, the minus, the division, the multiplication. And the logic being the less than, the greater than, the equal sign. Now the value the operator operates on is known as the operand. The operand be like 1 plus 2. So that number 1 and number 2, those are the operands. Now that the operator operates on the operands. So the operator here will be a plus or a minus or a division or a subtraction. That will be the operator. But the operand is going to be like the number 1, the number 2, number 3, and 4, and so forth. So, what are the basic operators? Now remember, Python operators are the constructs which can manipulate the variable operands. Consider the expression 5 plus 3. Obviously, that's going to be 8. Now remember here, 5 and 3 are the operands. And the plus sign is what we call the operator. Now we have several types of operators. Now in Python programming, or Python language supports the following types of operators. We have the arithmetic operators, like 1 plus 2, 3 plus 3, 2 minus 2, Those are the arithmetic operators. And then we have the comparison. Which one will be compared, with the ones which will be comparing the relationships. So we can say the letter F in Fred comes before the letter George. So that makes it a comparison. So we can compare. F has to be first, then George. Fred has to be first, then George comes after Fred. And then we also have the assignment. The assignment operator will be, for example, plus sign. We assign, let's say, letter X to the addition of 5 plus 3, and then we keep it in X. So when we try to print X, we'll definitely get an 8. And then we have the logics, the logical operators. Is it greater than? Is it less than? Is it equal to? So the word equal to here, we use it to mean the equality. Is letter F equal sign letter G? So it's not going to be an operator. It's not going to be an assignment statement. We actually compare. We're doing a comparison. And then we have the bitwise operations, the ones and the zeros. And then we have the membership operators. And then we have the identity operators. So we are going to talk about each and every one of those.
Okay.
So the basic operator, a membership operator in Python can be defined as being an operator that is used to validate the membership of a value. Now, this operator is used to test membership in variables such as strings, integers, as well as tuples. Remember, we talked about the tuples when we talked about the variable types.
Yes.
I mean, the data types. So membership operator in Python can be defined as being an operator that is used to validate the membership of a value. Now, membership operators as a whole contain a number of different operators. Then we have the bitwise operator in Python. So bitwise operators in Python are functions and or methods that are used to perform bit operations. In simple terms, it is the process on converting integers and strings into bits that are zeros and ones. So in Python programming, we do basic English language, but the interpreter will be able to convert those integers and strings into bits. The bits are the zeros and the ones. So in a bitwise format, step by step, you take number 1, convert it to binary. Take number 3, convert it to binary, and then you say add those 2 to get number 4, which is also going to be converted to binary for the computer to interpret and give us the answer. So by using these operators, you are urging Python to either shift them from left to right or convert them into a sequence of zeros and ones. For example, when we talk of zeros and ones, when you look at something like this, the first 0 here will be starting from index 0. This one will be index 2. Index 0. This will be index 1, index 2, index 3. Now, I'll show you how we do the calculation here. So right now, these are just going to be typical examples. If you were to convert, let's say 0, 1, 0, 0, and we convert 1, 1, 0, 0, and then we convert 1, 0, 0, 0, there'll be a pattern of numbers. It can be 1, 2, 3, 4. But in order for computer to understand 1, 2, 3, 4, computer has to convert them into binary numbers. That's why you see 0, 1, 0, 0, 1, 1, 0, 0, 1, 0, 0, 0, and 1, 0, 0, 1. So there'll be I think in our next lesson, we're gonna go deep into this. So there'll be a little bit of math involved, but it's not. So in order to understand this better, we want to take a look at the example below. So we take 6, we put it in letter X. Now letter X is a memory location. It's a variable. So X is a variable, but X is an address in the memory. And then we'll take letter Y. Letter Y, we also assign it to a memory location in Y. So we say Y equals to 8 and X equals to 6. When converted, their values in binary form will be, if you divide, let's say you continually keep on dividing 6 by 2 and continually keep on dividing 8 by 2, and you only take the remainders, the numbers will be 0, 1, 1, 0 and 1, 0, 0, 1. Now let me see if I can annotate that so that you get it. All right. So if we say, okay, let me get a better one. What count number 6, eh?
Mm-hmm.
Then what count number 2?
Yeah.
2 b into 6 how many times?
3.
3. What remain give?
0.
0. Get to 0. 0 and 3 them. Then what check what okay. 2 b into 3 how many times?
Sure.
What remain give?
1.
King will take these numbers from here going up.
Okay.
Since we want to get even, we will have to add a 0 here, which in real sense is insignificant, but we just want to make them pair up. So we'll take from 1, we write 1 here. We take this one, we write that one there. We take the last one, we write this one here. And then Motimo, we just go ahead and add a 0. If you look, this is exactly what we have here. And this is a representation of number 6. Now, we can do the same also for number 8. So we say 2 goes into 8. How many times?
4.
What they can do 4 times, what remains again?
0.
0, 1 equals 0. 4, 1 equals. What divide 2 goes into 4 how many times?
0.
2 goes into 4?
Mm-hmm.
Twice. No, twice. Remain with 0. And then the last one, 2, pocket or 2 car. 2 goes into 2 1 time, which is 0. King here, we take it from here like that. Obubiro 1, 0, 0, 0. So these are 4, so it's paired up. For king your mind, king your number need. The same thing, Moidoka. And that's your binary conversion. Because the computer does it so fast, Maki wacho ni wadwa kawa beach. Wadwa rioga deck. Me and you, we know near 8 because we are humans. Computer will have to take this number, convert it into binary first. And then take this number, convert it into binary first. And then take two numbers which are both binary now, and then get the result. And that result is what is going to be number 8. So fast, we don't even have time to think. So if we were to take number 5 here, we divide 5 by 2. So what 2 goes into 5?
2 times.
Twice, yeah. What remains again?
1.
1. And then 2 goes into 2 and remain with 0. What do you pair again? Watching okay. Watch out 0, 1, 0, 1. Mana is the 5, right? Converted already. And then what do you got him another one here? Got him 2 into 3. Sorry. So 2 goes into 3.
1.
Once, don't. What remaining 1? And then kakuro kwa team, this one is lower than 2. So we just take those 2. 1, 1. From there. One madam and 2 zeros. We say those 2 zeros, that's going to be equivalent of 3. Now, if you take this one, you add to this one, which we will not do today, but that will what we call the binary addition. So we call 0, 1, 0, 1. Then we'll add those 2. If we do this addition, which I don't want to do now, it's going to be overwhelming. The answer will be the conversion of this one, which is going to be 1,000, which is 10000. For example, if we add 1 plus 1 in binary, is equals to 0. But remember, we're carrying 1 here. 1 plus 1 is 0, plus 0 is going to be 0.
0.
And then we're going more carry can get 1 plus 1 is 0, carry 1. Then 1 plus 1 is 0, but we carry 1 here. So 1 plus 1 is again
0.
We'll carry 1. Then more 1 plus 0 is
1. If
you look at that, this is the same thing here. That's how the computer works.
more.
No, it's okay. We go to teacher.
I did a punch up at the capi.
Huh?
But I never thought about it like that, but it's okay.
Yeah, the one we just did is what we call converting integers or decimals into binaries. And then adding those binary numbers, more come up godogo. And then wayudo, the equivalent, which if you come here, in 1,000, 1,000 when you look at the car.
So it's standardly or divided by 2, regardless.
Yeah, because it's by is 2.
Okay.
We'll be talking over other base, but this base 2. You and me, we can only count in base 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 20. That's 40. Mago base 10. Me and you, we understand base 10. But base 2 are in a computer. Computer works very well in base 2. So if you were to take this one, what would check one this thing from what check 1, 0, 1, 2, 3. These are all the index numbers for the positions of these characters. Now, if we will do that next time, but when we do all this, when you convert binary back into decimal, by just using that.
Interesting.
Yeah. So why is this even important? The reason why we are doing this so that we understand the intricacies of how the computer works. Mondo, you need to solve a problem without even knowing how to solve that problem. It's very good to understand the problem.
Yeah, that's true.
So in this case, we want to know what the computer deals with so that we know exactly how it approaches that problem so we understand it. So these are the numbers. Now, when you go into letters, we'll have so many other stuff which are also different when it comes to the ASCII, America's Standard of Code, Information Interchange. So we'll be able to understand those, like when you do stuff at the keyboard, how does the computer know that's an A, capital A or small a? Mm-hmm. How does the computer know if that's a B, capital B or small b? So all those will matter. And I'll be able to show you those ones. Hopefully by tomorrow, we'll be able to finish this slide deck and then we move to the next one. But this is being recorded, so don't even feel bad. This one, at your own time, just get enough time to go through it.
Yeah, I have to go through it, omit.
So key timo conversion of, we convert the binary to decimal. Convert the binary to decimal.
Oh, binary to decimal, okay.
Yeah, to decimal. So how you can get this 1001 or 1000 back into decimal.
Okay.
Yeah. So it goes bit by bit. That's why we call the bitwise operator. Yeah.
It's very interesting.
Yeah, you'll be amazed what happens behind the scenes. And in a split of I don't know, millisecond, if I may count, within no time, we'll say it. You can give the computer a big number, within no time, it's done.
So it's done. Or convert so fast.
So fast. Mm-hmm.
Okay.
Come on. Any question for me?
Not now. I'm just playing with stuff in my mind.
That's a good thing. Yeah, so I recorded it. I'll send you a recording.
Yeah, send me a call over before I need again.
No problem. Will do. All right, Fred. Thank you.
You're welcome. Thank you so much.
No problem. Thank you.
I'll wait for the recording.
Okay, will do.
Okay, bye.